Unit 4, Lesson 4. So we have taken the time to learn everything we know about exponents, all our exponent rules, what to do with negative exponents, what to do with zero exponents, and what to do with fraction exponents. Now we're going to put that all together. So one important thing is that the rule for fractional exponents is a tool for evaluating, much like the rule for zero exponents. It should be used only after all the other exponent rules. So if you're looking at a question and you're going to use an exponent rule, you should first do the power of a power rule. Second, do your multiplication or division rules. And last, your zero, negative, or fraction rules. They should be left to the very end. So I'll show you a couple of examples to help explain what I mean. So I see in question 1, 3 to the 1/2 times 3 to the 3/2. I see that there is multiplication in that question. So I am going to do my multiplication rule first before I try to do my fraction rule, which means take the root. So if I do my multiplication rule, I keep the base and I add my exponents. And to add fractions, you have to have the same denominator, common denominator, which I already have. When you have a common denominator, it stays the same, and you add the numerator. So 3 plus 1 is 4. And 4 over 2 simplifies to just 2. So I've got 3 squared, which is 9. So often when you do your multiplication, division rules, power rule first, the other stuff work their way out so that you don't have to do the hard things like taking the roots or flipping things like with negative exponents. So if I look at number 2, number 2 is 1 base and 2 exponents. So I'm going to multiply my exponents and keep the base. So to multiply fractions, I need to have a top number and a bottom. If I have a number that does not have a bottom number, does not have a denominator, I can give it a denominator of 1 every single time. When I multiply fractions, I multiply the numerators together and I multiply the denominators together. So I have negative 4 times 1 is negative 4 and 2 times 1 is 2. So I have negative 25. Negative 4 over 2 simplifies to negative 2. So be careful here because 2 negatives do not cancel out. A negative exponent and a negative number do not cancel the negatives. What happens is you have to evaluate the exponent. So way back when we were doing negative exponents, we learned that it makes a fraction or makes a number flip. So a negative 2 will make that 1 over negative 25 and make the exponent positive. And then negative 25 times negative 25 would be 625. So I would have 1 over 625, a fraction answer. Don't forget the 1 part. All right, let's try one with dividing. So dividing, same base. I'm going to keep the base. But this time when I'm dividing, I subtract my exponents. So when I subtract with fractions, I need to have a common denominator, which I do, and then I subtract my numerators. So negative 1 take away 1 is negative 2 over 2, which is 49 to the negative 1. Negative exponent means you flip it around and you have a fraction, 1 over 49. Okay, number 4, 16 3/4 times 16 to the 1/2. I have the same base and I'm multiplying, so I keep the base and I add my exponents. To add my exponents, I need a common denominator. This time I don't have a common denominator, so I need to make 1. And the way you make a common denominator is making an equivalent fraction. So I know 2 times 2 is 4, so the common denominator would be 4. That's 3/4, and then 1/2 would be 2/4, because 2 times 2 is 4 and 1 times 2 is 2. Now I can add my numerator, keep my denominator the same, and this time I'm going to have to do my fraction exponent. So I remember the bottom number is the root, and the top number is the exponent. So the 4th root of 16 is 2, and I have an exponent of 5. Whoops, 2 to the 5 would be 32. There we go. All right. Last two examples, whole bunch of stuff going on. So I see some multiplying in the brackets, but they're multiplying, but there is no base that's the same. If the base is not the same, I can't use my exponent rule. Remember your exponent rules. So I can't use my exponent rule. I can, however, use my power rule because it's multiplying in the brackets. So I put my 2 over 1 and I multiply all my exponents inside by exponent outside. So top times top would make 6, bottom times bottom would make 2. And I've got my base of 8, top times top would make 2, bottom times bottom would make 3. So because they're not the same base, I can't add them. So I'm going to have to do my bottom number is the root, top number is the exponent. Bottom number is the root, top number is the exponent, which gives me the square root of 9, 3 to the exponent 6, and the cube root of 8, 2 to the exponent 2. And 3 to the 6 is one I do not have memorized. I need to actually have my calculator. So 3 to the exponent 6 is 729 times 4. It's going to be a fairly big number, 2,916. And you can apply the same principle with variables, with letters. So I'm multiplying, same base, the same letter, I add my exponents. So I have a to the 3 plus 2/3, and I have b to the 4 plus a half. So 3 plus 2/3 is 3 2/3, or 11/3. And 4 plus a half is 4 1/2, or 9/2. Because you have no numbers, you can't evaluate, so you're done at this point with letters after you've used all your exponent rules. All right, 2 more quick examples. Sometimes in order to use your exponent rules, you've got to take and make sure you have exponents. So a root is not an exponent, but we do know that the number in front of the root is the denominator of an exponent, and the exponent outside the root is the numerator of an exponent. So I can work backwards and change my root 3 squared back to its fraction equivalent, 2 over 3. And now I should be able to use my power rule. Multiply my exponents, 2 over 6. And 2 over 6 would simplify to 1/3 because they both divide by 2, which would be the cube root of 64. So the bottom number is the root, and the cube root of 64 is 4. Last one, numbers and letters. So first thing I notice is this bracket with the exponent outside of it, power to a power. So I have to multiply all the exponents inside. So the term in front stays the same. I'm not going to worry about that negative exponent until there's nothing else that I can do. So 2 to the exponent 2 is 4. When I multiply, I'll put the outside exponent over 1. So I multiply my numerators and my denominators, and I get 4 over 3 and n to the 2 over 4. So I've done my power rule. Now I'm going to do my dividing. So I'll divide my numbers like normal. 8 divided by 4 is 2. And then I subtract my exponents. So I have 2/3 minus 4/3. And I've got negative a half minus 2/4. So if I simplify that, 2 take away 4 is negative 2/3. And negative a half take away a half, 2/4 is a half, would be negative 2 over 2. So if I have negative exponents, the negative exponents get flipped around to make them positive. So I have m to the 2/3, n to the 1, because 2 divided by 2 is 1. And that's as far as I can go with that one. So these get kind of tricky. Pay close attention to your exponent rules and your fraction rules for adding and subtracting, multiplying, and dividing.